What's happening, folks? Back for the next installment in our watch-along of Carl Sagan's Cosmos, A Personal Voyage, shot in the late 70s, airing over the course of 80 and 81. I admit I'm a bit dismayed. I've had the box set of these DVDs for a very long time, and the first episode and the second episode played with no issues, although the second episode took a moment to load up. But when I tried to watch the third episode on the second disc, it didn't load, and I eventually had to use a folder of files that I downloaded of Cosmos. When I began putting samples into my mixes, I didn't know how to extract audio from DVDs, so I would take files that I found online and I downloaded the whole Cosmos series so that I could start sampling it. And yeah, I had to use that for the third episode. Well, the same thing when I loaded up the third disc, which includes episodes 4 and 5, it just would not load in either of my main media players. So I don't know what's happened to my disc. Admittedly, I've had them for like 20 years now, so, or at least close to that. So maybe they just, they haven't stood the test of time, and for whatever reason they don't read in more modern players. But yeah, it's a bit unfortunate, but thankfully I do have the files in that folder. So in any case, we're going to watch episode 4, which is given the subtitle or the title, Heaven and Hell. And I'll just let Carl explain what that's about. Again, when we watch these Sagan Cosmos episodes, I may comment a bit less frequently than I do when we watch TV shows or movies, so that's just the nature of the game, but let's get to it. This is episode 4 of Carl Sagan's Cosmos, A Personal Voyage, and it's called Heaven and Hell. And then he immediately pauses. I will say, though, Sagan was talking in episode 3 about how the stars are comforting. They provide a backdrop to our existence here on Earth, and they allow us to project our fears and our hopes and our dreams, and also, of course, are, in a very real sense, faraway suns. But I feel like the opening of the Cosmos series itself gives me this comforting at-home feeling, which I've felt for a long time, but going through this watch-along and watching the series for the first time in at least a few years, it's really hitting me every time we start an episode.
This is the age of planetary exploration, when our ships have begun to sail the heavens. In those heavens, there are some worlds much like hell. Our planet is, in comparison, much like a heaven. But the gates of heaven and hell are adjacent and unmarked.
I love that phrase, and I feel like not just in terms of astronomy and planetary science, there's lots of aspects of human existence, culture, politics, society, where stark and divergent outcomes are related, or at least are equally possible, and hard to tell which path one is heading down without greater knowledge, which is, of course, the endeavor of science, trying to understand, not just to act based on impulse or emotion or cultural attitudes and so on. But yeah, I love that the gates of heaven and hell are unmarked and adjacent.
Comparison, much like a heaven, but the gates of heaven and hell are adjacent and unmarked. The Earth is a lovely and more or less placid place. Things change, but slowly. You can lead a full life and never encounter anything in the way of a natural catastrophe more violent than a storm. And so we become complacent, relaxed, unconcerned. But in the history of the solar system, and even in human history, there are clear records of extraordinary and devastating catastrophes. We humans have now achieved the dubious distinction of being able to make our own major catastrophes, both intentional and inadvertent. On the landscapes of other planets, where the records of the past are better preserved, there is abundant evidence of major catastrophes. It's all a matter of timescale. An event which is improbable in 100 years may be inevitable in 100 million. But even on the Earth in this century, there have been bizarre natural events.
In remote central Siberia, there was a time when the Tunguska people told strange tales of a giant fireball that split the sky and shook the earth.
Now, this is one of, I think, only a couple over the course of the entire series moments in the show where Sagan, not in any definitive way, but he puts forward a hypothesis based on what was then more or less the consensus understanding that I think has since been shown to be an error. I'll wait till we get to the moment where he talks about it in more detail, but yes, I will provide a little extra commentary here because this is one of only, I think, 2 or 3 at most moments where further information over the intervening decades has suggested that it was, in fact, something different.
In remote central Siberia, there was a time when the Tunguska people told strange tales of a giant fireball that split the sky and shook the earth. They told of a blast of searing wind that knocked down people and whole forests. It happened, they said, on a summer's morning in the year 1908. In the late 1920s, L.A. Kulik, a Soviet scientist, organized expeditions to try and solve the mystery. He built boats to penetrate this trackless land, snowbound in winter, a swampy morass in summer. Eyewitnesses told of a ball of flame larger than the sun that had blazed across the sky 20 years before. Kulik assumed a giant meteorite had struck the Earth. He expected to find an enormous impact crater and rare meteorite fragments chipped off some distant asteroid. However, at ground zero, Kulik found upright trees stripped of their branches, but not a trace of the meteorite or its impact crater. He was deeply puzzled, but he thought perhaps there were meteorite fragments buried in the swampy ground. So he set about digging trenches and pumping out the water, but the expected meteoritic rock and iron was nowhere to be found. Undaunted, Kulik went on to make a thorough survey, despite the swarms of insects and other hardships, because he had discovered something that, in his own words, exceeded all the tales of the eyewitnesses and my wildest expectations. For more than 20 kilometers in every direction from ground zero, the trees were flattened radially outward like broken matchsticks. There must have been a powerful explosion several kilometers above the ground. The pressure waves spreading out at the speed of sound has been reconstructed from barometric records at weather stations across Siberia, through Russia, and on into Western Europe. Dust from the explosion reflected so much sunlight back to Earth that people could read by it at night in London, 10,000 kilometers away.
This really remarkable occurrence is called the Tunguska event. But what was it? Well, perhaps some scientists have suggested it was a chunk of antimatter from space, annihilated on contact with the ordinary matter of the Earth, disappearing in a flash of gamma rays. But the radioactivity that you'd expect from matter-antimatter annihilation is to be found nowhere at the impact site. Or perhaps, other scientists have suggested, it was a mini black hole from space which impacted the Earth in Siberia, tunneled its way through the solid body of our planet, and plunged out the other side. But the records of atmospheric shock waves give not a hint of something booming out of the North Atlantic later that day. Or maybe other people have speculated it was a spaceship of some unimaginably advanced extraterrestrial civilization in desperate mechanical trouble, crashing in a remote region of an obscure planet. Well, if so, it's pretty startling that at the impact site there's not a piece, not the tiniest transistor of a crashed spacecraft. More prosaically, perhaps it was a large meteorite or a small asteroid which hit the Earth. But even here, there are no observable telltale rocky or metallic fragments of the sort that you'd expect from such an impact. The key point of the Tunguska event is that there was a tremendous explosion, a great shock wave, many trees burned, an enormous forest fire, and yet no crater in the ground. There seems to be only one explanation which is consistent with all these facts, and that explanation is this. In 1908, a piece of a comet hit the Earth.
Now again, my understanding is that that explanation is no longer consensus, and I think, if I'm remembering correctly, that there is the conviction that it was in fact a meteor, but it must have been a small meteor or something to that effect, and it did explode well above the ground, and perhaps most of the pieces were incinerated, so there weren't metallic fragments, parts of a meteorite that were there to be discovered after the fact. I wonder if in this DVD, because in this, oh no, it doesn't have any, it wants me to add them. Well, yes, obviously this doesn't have the science updates, which is to say, on the DVDs, there's a subtitle option you can activate that's called science updates, and in a lot of cases it just says, oh, this has turned out to be true, and this study later in the 90s confirmed it through this measurement and so on. But in a couple cases it says, actually, this is no longer considered the most likely explanation, and this is one of those cases. So I forget what the subtitles for the science updates say here, because apparently they're not part of these files that I downloaded years ago. But in the DVD, we might get a fuller explanation. But that's where I remember learning that, oh, wait a minute, so this actually isn't the consensus. But if I'm recalling correctly, I think it is now considered to be a meteorite, or rather a meteor that exploded in the atmosphere, but for one reason or another, the typical remnants, including an impact crater, weren't part of the aftermath or the impact. So, yeah.
And that explanation is this. In 1908, a piece of a comet hit the Earth.
No one saw it approach, a small point of light lost in the glare of the morning sun. It had been drifting for centuries through the inner solar system, like an iceberg in the ocean of interplanetary space. But this time, by accident, there was a planet in the way. From the time and direction of its approach, the object that hit the Earth seems to have been a fragment of a comet named NK, hurtling at more than 100,000 kilometers an hour. It was a mountain of ice about the size of a football field and weighing almost 1 million tons. There was no warning until it plunged into the atmosphere.
Side note, this is part of Igor Stravinsky's Rite of Spring, which I had heard since I was young. Again, my dad was into classical music, and I heard a lot of it growing up. But I think many people will associate it with the Fantasia original movie, the Walt Disney movie Fantasia, because the extinction of the dinosaurs is shown with this as a musical backdrop in that film.
If such an explosion happened today, it might be thought, especially in the panic of the moment, to be produced by a nuclear weapon. Such a cometary impact and fireball simulates all the effects of a 15-megaton nuclear burst, including the mushroom cloud, with one exception: there would be no radiation. So, could a rare but natural event, the impact of a comet with the Earth, trigger a nuclear war?
It's a strange scenario. A small comet hits the Earth, as millions of them have during the history of our planet, and the response of our civilization is promptly to self-destruct. Maybe it's unlikely, but it might be a good idea to understand comets and collisions and catastrophes a little bit better than we do.
Obviously, that is absolutely true, just in a general scientific sense. And of course, this show was made during perhaps one of the most perilous and dangerous periods of the larger Cold War between East and West, between, in particular, the US and the Soviet Union. So the idea, again, it's sort of similar to Nana's 99 Luftballons, right? Like the idea that someone sees something on a radar screen, assumes it's a weapon, hits a button, and that makes other people in other control rooms hit buttons, and the entire world destroys itself over what was fundamentally a child's toy. And here, again, a natural phenomenon, and as he said, whatever the truth about the Tunguska, the Tunguska event, comets have hit the Earth in the past, and the idea that something as natural as that could lead to an intelligent technological species destroying itself would not only be tragic and ironic, but it's entirely possible. And indeed, let me use my phone to see if I can look up the current consensus view of this incident, just for clarification. 1 second. Okay, so it was basically as I was thinking, that there still is some debate in the scientific community as to precisely what it is or what it was, but the largest consensus is that it was a smaller meteor that experienced what they call an airburst. That is to say, it exploded with the impact of the gaseous atmosphere of Earth and blew up multiple miles over the surface of the Earth. So there was no impact crater, and the pieces were largely incinerated, especially because it was a smaller meteor. So that's why there was no crater, and that's why there were no fragments, to any significant degree. So yeah, again, there's still a little debate, but it seems like it was a meteor that burst in the air, or what they call a meteoric airburst. And there are still people who think it might have been a comet. There's still some other explanations, but yeah, ultimately that does seem to be the main consensus view at this point. So away we go.
Now, a comet, at least as far as we understand them today, is made mostly of ice. Water ice, maybe some ammonia ice, a little bit of methane ice. So in striking the Earth's atmosphere, a modest cometary fragment will produce a great radiant fireball and a mighty blast wave. It'll burn trees and level forests and make a sound heard around the world, but it need not make a crater in the ground. Why? Because the ices in the comet are all melted in the impact, and there's going to be very few recognizable pieces of comet left on the ground.
We humans like to think of the heavens as stable, serene, unchanging. But comets suddenly appear and hang ominously in the sky night after night for weeks.
So the idea developed that the comet had to be there for a reason. And the reason was that comets were kind of predictions of disaster, that they foretold the deaths of princes and the fall of kingdoms. In 1066, for example, the Normans witnessed an apparition or appearance of Halley's comet. Since a comet must, they thought, predict the fall of some kingdom, they promptly went ahead and invaded England. Here's King Harold of England looking a little glum. The events were noted in the Bayeux Tapestry, a kind of newspaper of the day. Or in the early 13th century, Giotto, one of the founders of modern realistic painting, witnessed another apparition of Comet Halley and inserted it into a nativity he was painting, a harbinger of a different sort of change of kingdoms. Around 1517, another great comet appeared. This time was seen in Mexico, and the Aztec emperor Moctezuma, maybe this is he, promptly executed his astrologers. Why? Well, they hadn't predicted the comet, and they sure hadn't explained it. Moctezuma was positive that the comet foretold some dreadful disaster. He became distant and gloomy, and in that way helped to set the stage for the successful Spanish conquest of Mexico under Cortez. In many cases, a superstitious belief in comets becomes a self-fulfilling prophecy. Here are two quite different representations of the great comet of 1577. This one pictured by the Turks, and this one by the Germans. In 1705, Edmund Halley finally figured out that the same spectacular comet was booming by the Earth every 76 years, like clockwork. That comet is now called, appropriately, Comet Halley, and it's the same one that we talked about a moment ago, the comet of 1066. At that point, the subject began to lose a little of its burden of superstition, but hardly all. Public fear of comets survived, and, well, for example, look at this terribly nasty comet of 1857 that some people figured would splinter the Earth. By 1910, Halley's comet returned once more, but this time astronomers using a new tool, the spectroscope, had discovered cyanogen gas in the tail of a comet.
More on that in a moment. But I do remember, I was born in 1980, and for most of 86 I was 5, so I don't remember exactly what month it was. But I do remember when Halley's Comet returned, and there was, much talk of it in the newspaper, and I remember, my parents talking about it and the idea that it was something that would happen once in a lifetime, essentially. So, yes, maybe if I'm lucky enough to live long enough, I will see it return. But I definitely remember that in the mid-'80s, where Halley's Comet was a cultural phenomenon.
Now, cyanogen is a poison. The Earth was to pass through this poisonous tail. The fact that the gas was astonishingly, fabulously thin reassured almost nobody. So, for example, take a look at the headlines in the Los Angeles Examiner for May 9th, 1910. Say, has that comet cyanogened you yet? Entire human race due for free gaseous bath. Expect hijinks. Or take this from the San Francisco Chronicle, May 15th, 1910. Comet comes and husband reforms. Comet parties now fad in New York. Amazing stuff. In 1910, people were holding comet parties, not so much to celebrate the end of the world as to make merry before it happened. There were entrepreneurs who were hawking comet pills. I think I'm going to take one for later. And there were those who were selling gas masks to protect against the cyanogen. And comet nuttiness didn't stop in 1910.
Long before 1066, humans marveled at comets. Our generation is beginning to understand them.
The sound in that part, I remember now, always amused me. You can hear people talking, he's in a big room where other people are. Then we hear a goat, which I guess maybe is used to give a little sonic atmosphere to that nativity painting. But yeah, that moment always was a curious thing for me.
Is beginning to understand them. Mercury, Venus, Earth, and Mars are small planets made mostly of rock and iron. Farther out, where it's colder, are the giant planets made mostly of gas. But comets originate from a great cloud beyond the planets, almost halfway to the nearest star. Occasionally, one falls in, accelerated by the sun's gravity. Because it's made mostly of ice, a comet begins to evaporate as it approaches the sun. The vapor is blown back by the solar wind, forming the cometary tail. Then it's flung back into outer darkness, its orbit so large that it will not return for millions of years. These are the long-period comets, and for everyone plunging close enough to the sun to be discovered, there may be 1 billion others slowly drifting beyond Pluto's orbit. Very rarely, a long-period comet is captured in the inner solar system, becoming a short-period comet. It passes near a major planet like Saturn. The planet provides a small gravitational tug, enough to deflect it into a much smaller orbit. Although few comets are captured this way, those that are become well known because they all return in relatively short intervals. Once trapped in the inner solar system, among the planets, the chances of another near collision are increased. Here, a second encounter with Saturn further reduces the comet's orbital period to decades. A comet may take 10,000 years between close planetary encounters, but in this computer study, we've sped things up. A third encounter, this time with Jupiter, further reduces the comet's orbital period. Now, the comet must approach the sun and grow a tail every few years. Since the dust and gas in the tail are lost forever to space, the comet must slowly be eroding. Pieces of it break off. Sometimes, as we've seen, they even strike the Earth. In a few thousand years, if a short-period comet hasn't hit a planet, it will have evaporated away almost entirely, leaving sand-sized fragments which become meteors, and its core, which perhaps becomes an asteroid.
Suppose I were a pretty typical comet. Then what you would see would be a kind of a tumbling snowball, spending most of my time out here in the outer solar system. I'd be a kilometer across. I'd be living most of my days in the gloom beyond Saturn, orbiting the sun. But about once every century, I would find myself careening inward, faster and faster, towards the inner solar system. By the time I would cross the orbit of Jupiter on my way to the orbit of Mars, I'd be heating up because I'd be getting closer to the sun. I'd be evaporating a little bit, and small pieces of dust and ice would be blown behind me by the solar wind, forming an incipient cometary tail. On the scale of such a solar system model, me, a cometary nucleus, would be smaller than a snowflake. Although when fully developed, my tail would be longer than the spacing between the worlds. Now, sooner or later, comets on these long elliptical trajectories around the sun must collide with planets. The Earth and the Moon must have been bombarded by comets and asteroids, the debris from the early history of the solar system. In interplanetary space, there are many more small objects than large objects, so there must be, on a given planetary surface, many more impacts of small objects than of large objects. So a thing like the Tunguska impact happens on the Earth maybe every 1,000 years, but the impact of a giant cometary nucleus like Halley's Comet, let's say, happens only every billion years or so. Now, is there evidence of past collisions?
When a large comet or a large rocky asteroid hits a planet, it makes a bowl-shaped crater. The few well-preserved impact craters on Earth were all formed fairly recently. The older ones have been softened, filled in, or rubbed out by running water and mountain building. Impacts make craters on other worlds, and about as often. But when the air is thin, when water rarely flows, when mountain building is feeble, the ancient craters are retained. This is the case on the Moon and Mercury and Mars, our neighboring terrestrial planets.
They huddle around the sun, their source of heat and light, a little bit like campers around a fire. All of them are about 4.5 billion years old, and all bear witness to an age long gone of major collisions which do not happen at that scale and frequency anymore.
I'm trying to remember. I do think, well, not only is that section very interesting in that, you know, the planetary forces here on Earth mean that craters are eroded over time, and so the evidence of them on the Earth's crust is less clear, whereas again on the Moon, that is where it's airless and mountain building doesn't happen, as well as Mars, there is a greater physical record of planetary impacts by comets and or asteroids or meteors. But I was also thinking that that whole section, not only about the impacts of meteors, but also about the planets being, campers huddled around a fire, I've sampled in multiple mixes, and Age Long Gone is one that I think of right away. So again, as we go through Cosmos, I'm just going to keep recalling mixes where I've used a lot of these lines.
All bear witness to an age long gone of major collisions which do not happen at that scale and frequency anymore. If we move out past the terrestrial planets, beyond Mars, we find ourselves in a different regime of the solar system, in the realm of Jupiter and the other giant or Jovian planets. These are great worlds composed largely of the gases hydrogen and helium, some other stuff too. When we look at the surface, we do not see a solid surface, but only an occasional patch of atmosphere and a complex array of multicolored clouds. These are serious planets, not fragmentary little worldlets like the Earth. In fact, 1,000 Earths would fit in the volume of Jupiter. If a comet or asteroid were to accidentally impact Jupiter, it would be very unlikely to leave a crater. It might make a momentary hole in the clouds, but that's it. Nevertheless, we know that the outer solar system has been subject to a many billion-year history of impact cratering.
More on that maybe, I think, in the special update at the end of the episode, because again, we know those are included in these files. But the comet Shoemaker-Levy eventually did hit Jupiter, and most of the pieces, like it broke up as it got closer, and the tidal forces of Jupiter sort of ripped it apart. But when those pieces entered Jupiter's atmosphere and the clouds, there were massive explosions and like fireballs, and it was, an astronomer's dream. Like, I think they got a lot of really interesting and enlightening footage and data that was, returned by like probes and or satellites or telescopes that were watching Jupiter at the time. So yes, in our lifetime, I don't remember. I mean, again, if it's by the time they did this update at the end of the episode, then I suppose it was during Sagan's lifetime. But after they shot this, there was actually an observed incident of a comet hitting Jupiter, hitting in scare quotes.
Jupiter's moon Callisto is studded with thousands of craters, clear evidence of ancient collisions beyond Mars. And there are craters on other moons of Jupiter. Most of the thousands of large craters on our own moon were excavated billions of years ago. But were any recorded in historical times, the odds against it are about 1,000 to 1. Nevertheless, there's a possible eyewitness account of just such an event. It was the Sunday before the feast of St. John the Baptist, in the summer of 1178. The monks of Canterbury Cathedral had just completed their evening prayers and were about to retire for the night. The scholarly brother Gervais returned to his cell to read, while some of the others went outside to enjoy the gentle June air. In the midst of their recreation, they chanced to witness an astonishing sight, a violent explosion on the moon. This was a time when the heavens were thought to be changeless. The moon, the stars, and the planets were deemed pure because they followed an unvarying celestial routine. They were expected to behave without unseemly disruptions, like monks in a monastery. Was it wise to discuss such a vision? In every time and culture, there are pressures to conform to the prevailing prejudices. But there are also, in every place and epoch, those who value the truth, who record the evidence faithfully. Future generations are in their debt. A fire on the moon. Might it be some portent of ill fortune? Should the chronicler of the monastery be told? Was this event an apparition of the evil one? Gervaise of Canterbury was a historian, considered today a reliable reporter of the political and cultural events of his time. This is his account of the eyewitness testimony he was given. Now there was a bright new moon, and as usual in that phase, its horns were tilted toward the east. And suddenly, the upper horn split in two. From the midpoint of this division, a flaming torch sprang up, spewing out over a considerable distance, fire, hot coals, and sparks. After these transformations, Gervaise continued, the moon from horn to horn, that is along its whole length, took on a blackish appearance. Gervaise took depositions from all the eyewitnesses. He later wrote, the present writer was given this report by men who saw it with their own eyes, and are prepared to stake their honor on an oath that they have made no addition or falsification. Gervaise committed the account to paper, enabling astronomers 8 centuries later to try and reconstruct what really happened. It may be that 200 years before Chaucer, 5 monks saw an event more wonderful than many another celebrated Canterbury tale.
Quick side note, when I was in high school, I had to read a Middle English version of Chaucer's Canterbury Tales, and it was very difficult in that Middle English, if you didn't know, is quite different from English of more recent centuries, and I think is more Germanic in its spelling and syntax. And so I remember, we read part of it in, let's say, more modern or regular English, but we read one of the tales entirely in Middle English, and yeah, it was very difficult. So yeah, shout out to Chaucer. But I do like the idea that he said earlier that there are people who, despite being embedded in cultural, religious, and social systems of their day, and in those systems there is often a not only desire in many cases, but a compulsion to conform to prevailing views, to not challenge dogma or pre-established ideas. But there are people who simply have a respect for facts and try to understand in the most intellectual way possible, and thus have recorded data that centuries or even millennia later can be analyzed and interpreted with more modern understandings and instruments. So shout out to Gervaise of Canterbury.
That 200 years before Chaucer, 5 monks saw an event more wonderful than many another celebrated Canterbury tale. If a small drifting mountain were to hit the moon, it would set our satellites swinging like a bell. Eventually the tremors would die down, but not in a mere 800 years. So is the moon still quivering from that impact? The Apollo astronauts emplaced arrays of special mirrors on the moon. Reflectors made by French scientists were also put on the moon by the Soviet Lunokhod vehicles. When a laser beam from Earth strikes one of these mirrors and bounces back, the round-trip travel time can be measured. At the McDonald Observatory of the University of Texas, a laser beam is prepared for firing at the reflectors on the moon, 380,000 kilometers away. By multiplying the travel time by the speed of light, the distance to that spot on the moon can be determined to a precision of 7 to 10 centimeters, the width of a hand. When such measurements are repeated over a period of years, even an extremely slight wobble in the moon's motion can be determined. The accuracy is phenomenal. The error is much less than 1/1,000,000%. The moon, it turns out, is gently swinging like a bell, just as if it had been hit by an asteroid less than 1,000 years ago. So there may be physical evidence in the age of spaceflight for the account of the Canterbury monks in the 12th century. If 800 years ago a big asteroid hit the moon, the crater should be prominent today, still surrounded by bright rays, thin streamers of dust spewed out by the impact. In billions of years, lunar rays are eroded, but not in hundreds. And there is a recent ray crater called Giordano Bruno, in exactly the region of the moon where an explosion was reported in 1178.
Shout out to Giordano Bruno, a notable figure in the history of the heliocentric understanding of the solar system, and indeed he argued against the geocentric view, which was predominant and considered dogma. And unlike Galileo, he suffered much more significantly and extensively, and in fact the Neil deGrasse Tyson Cosmos will talk about Mr. Bruno in more detail, though we will get another mention of him along the way in this Cosmos.
Hundreds. And there is a recent ray crater called Giordano Bruno, in exactly the region of the moon where an explosion was reported in 1178. The entire evolution of the moon is a story of catastrophes. 4.5 billion years ago, the moon was accreting from interplanetary boulders, and craters were forming all over its surface. The energy so released helped melt the crust. After most of this debris was swept up by the moon, the surface cooled. But about 3.9 billion years ago, a great asteroid impacted. It generated an expanding shockwave and remelted some of the surface. The resulting basin was then flooded, probably by dark lava, producing one of the dry seas on the moon. More recent impacts excavated craters with bright rays named after Eratosthenes and Copernicus. The familiar features of the man in the moon are a chronicle of ancient impacts. Most of the original asteroids were swept up in the making of the moon and planets. Many still orbit the sun in the asteroid belt. Some, themselves almost fractured by gravity tides and by impacts with other asteroids, have been captured by planets, Phobos around Mars, for example, or a close moon of Jupiter called Amalthea. Somewhat similar to the asteroid belt are the rings of Saturn, composed of millions of small, tumbling, icy moonlets. Maybe the rings of Saturn are a moon which was prevented from forming by the tides of Saturn, or maybe it's the remains of a moon that wandered too close and was torn apart by the tides of Saturn. It's certainly a lovely place. Jupiter also has a newly discovered ring system which is invisible from the Earth. Now, there is a curious argument alleging major recent collisions in the solar system proposed by a psychiatrist named Emmanuel Velikovsky in 1950.
I'll just mention that a lot of this upcoming monologue is not only an interesting lesson in the history of scientific practice and the suppression of ideas and the way that true science thrives by experimenting hypotheses and essentially trying to falsify hypotheses, meaning you take an idea, you don't like, oh, we can't talk about this because it's, it might not be true, or it might go against like the current dogma and so on. And that's one of the points that Sagan is about to make. But you try to test a hypothesis, even if it's, an outlier or an unusual hypothesis. And that's the way that you might arrive at more valid perspectives. And I say arise because a lot of this upcoming monologue I sampled in a Psytrance mix that is on my YouTube called Arise.
He suggested that an object of planetary mass, which he called a comet, was somehow produced in the Jupiter system. He doesn't say exactly how it's produced, but maybe it's spat out of Jupiter. Anyway, however it was made, some 3,500 years ago, he imagines. It made repeated close encounters with Mars, with the Earth-Moon system, having as entertaining biblical consequences the parting of the Red Sea so that Moses and the Israelites could safely avoid the host of Pharaoh, and the stopping of the Earth's rotation at the moment that Joshua commanded the sun to stand still in Gibeon. He also imagined that there was extensive flooding and the volcanoes all over the Earth at that time. Well, then after a very complicated game of interplanetary billiards is completed, Velikovsky proposed that this comet entered into a stable, almost perfectly circular orbit, becoming the planet Venus, which he claimed never existed until then. Now, these ideas are almost certainly wrong. There is no objection in planetary astronomy to collisions. We've seen collision fragments and evidence throughout the solar system. The problem is with recent and major collisions. In any scale model of the solar system like this, it's impossible to have both the sizes of the planets and the sizes of their orbits to the same scale, because then the planets would be too small to see. If the planets were really to scale in such a model as grains of dust, it would then be entirely clear that a comet entering the inner solar system would have a negligible chance of colliding with a planet in only a few thousand years. Moreover, Venus is a rocky and metallic hydrogen-poor world, whereas Jupiter, the place that Velikovsky imagines it comes from, is made of almost nothing but hydrogen. There's no energy source in Jupiter to eject planets or comets. If one did enter the inner solar system, there is no way it could stop the Earth from rotating, and if it could, there's no way the Earth could start up rotating again at anything like 24 hours a day. There's no geological evidence for flooding and volcanism 3,500 years ago. Babylonian astronomers observed Venus in its present stable orbit before Velikovsky said it existed, and so on. There are many hypotheses in science which are wrong. That's perfectly all right. It's the aperture to finding out what's right. Science is a self-correcting process. To be accepted, new ideas must survive the most rigorous standards of evidence and scrutiny. The worst aspect of the Velikovsky affair is not that many of his ideas were wrong or silly or in gross contradiction to the facts. Rather, the worst aspect is that some scientists attempted to suppress Velikovsky's ideas. The suppression of uncomfortable ideas may be common in religion or in politics, but it is not the path to knowledge, and there's no place for it in the endeavor of science. We do not know beforehand where fundamental insights will arise from about our mysterious and lovely solar system. And the history of our study of the solar system shows clearly that accepted and conventional ideas are often wrong, and that fundamental insights can arise from the most unexpected sources.
Again, that whole section is sampled in my mix Arise, but I love that idea that the suppression of uncomfortable views might be commonplace, even considered desirable in politics or in religion, but there's no place for it in the endeavor of science. It just is one of the principles that I remember really sort of electrifying my brain when I was watching this as a 20-something.
Clearly, that accepted and conventional ideas are often wrong, and that fundamental insights can arise from the most unexpected sources.
We've evolved on the planet Earth, and so we find it a congenial place. But just next door is Venus, until recently enveloped in mystery.
This part I remember also being very interested by, because for whatever reason, you know, I had learned a little bit about Venus during my school years, and I remember learning that a lot of the information we know about it came much more recently than in relation to some other planets, and also that it was incredibly hot. And so when I got to this episode, I was like, oh, like, I'm very excited to learn more details about this. And the history of our study of Venus is, I think, a very telling example of what Sagan was just talking about, the difference between, or rather what he was talking about, especially maybe in the first episode, that, we can speculate. That's part of the theoretical side of science, but that speculation has to be regarded as such and always measured against what the data suggests.
It has almost the same size and mass as the Earth. Might our sister world be a balmy summer planet, a little warmer than the Earth because it's a little closer to the sun? Are there craters, volcanoes, mountains, oceans, life?
The first person to look at Venus through a telescope was Galileo in 1609. But all he could see was a featureless disk. And as optical telescopes got bigger, that's all anybody could see. A disk with no details on it at all. Venus evidently was covered with an opaque layer, thick clouds concealing the surface. For centuries, even the composition of the clouds of Venus was unknown. I mean, you could go outside, look up, see Venus with the naked eye, observe sunlight reflected from the clouds of Venus. What were you looking at? What were the clouds made of? Nobody knew. As a result, imagination ran riot. The absence of anything you could see on Venus led some scientists and others to deduce that the surface was a swamp. The argument, if we can dignify it with such a phrase, went something like this. I can't see a thing on the surface of Venus. Why not? Because it's covered with a dense layer of clouds. Well, what are clouds made of? Water, of course. Therefore, Venus must have an awful lot of water on it. Therefore, the surface must be wet. Well, if the surface is wet, it's probably a swamp. If there's a swamp, there's ferns. If there's ferns, maybe there's even dinosaurs. Observation, you couldn't see a thing. Conclusion, dinosaurs. Well, if just looking at Venus was so unproductive, what else could you do? The next clue came from early work with that, a glass prism. An intense beam of ordinary white light is made to pass through a narrow slit and then through the prism. The result is to spread the white light out into its constituent rainbow of colors. This rainbow pattern is called a spectrum. Think about it. White light enters the prism. What comes out of the prism is colored light. Lots of colors. Where did they come from? They must have been hiding in the white light. White light must be a mixture of many colors. Here we see the spectrum running from violet, blue, green, yellow, orange to red. Since we see these colors, we call this the spectrum of visible light.
The sun emits lots of visible light. The air is transparent to it, so our eyes evolved to work in visible light. But there are many other frequencies of light which our eyes can't detect. Beyond the violet is the ultraviolet. It's just as real, but you need instruments to detect it. Beyond the ultraviolet are the X-rays and then the gamma rays. On the other side of visible light, beyond the red, is the infrared, again real, again invisible. Beyond the infrared are the radio waves.
Now this entire range from the gamma rays way over there to the radio waves all the way over here are simply different kinds of light. They differ only in the frequency. They're all useful, by the way, in astronomy. But because of the limitations of our eyes, we have a prejudice, a bias, a chauvinism to this tiny rainbow band of visible light.
Now, a spectrum can be used in a simple and elegant way to determine the chemical composition of the atmosphere of some distant planet or star. Different atoms and molecules absorb different frequencies or colors of light, and those absorbed or missing frequencies appear as black lines in the spectrum of the light we receive from the planet or star.
Each and every substance has a characteristic fingerprint, a spectral signature, which permits it to be detected over a great distance. As a result, the gases in the atmosphere of Venus at a distance of 60 million kilometers have been determined, their composition has been determined from the Earth. It's amazing to me still. We can tell what a thing is made out of at an enormous distance away without ever touching.
Our eyes can't see in the near-infrared part of the spectrum, but our instruments can. Here's the absorption pattern of lots and lots of carbon dioxide, dark lines in characteristic patterns at specific frequencies. You'd detect a different set of infrared lines if, say, water vapor were present.
If Venus were really soaking wet, then you should be able to determine that by finding the pattern of water vapor in its atmosphere. But around 1920, when this experiment was first performed, it was found the Venus atmosphere seemed to have not a hint, not a smidgen, not a trace of water vapor above the clouds. And so instead of a swampy, soaking wet surface, it was suggested that Venus was bone dry, a desert planet with clouds composed of fine silicate dust.
But later, spectroscopic observations revealed the characteristic absorption lines of an enormous amount of carbon dioxide. So some scientists thought there must be lots of carbon compounds on the surface, making this a planet covered with petroleum. Others agreed that the atmosphere was dry, but thought the surface was wet. With all that CO2, it had to be carbonated water. Venus, they thought, was covered with a vast ocean of seltzer.
Now, the first hint of the true situation on Venus came not from the visible or the ultraviolet or the infrared part of the spectrum, but from over here in the radio region. We're used to the idea of radio signals from intelligent life, or at least semi-intelligent life, radio and television stations.
Zing against us humans. Shout out to you, Sagan.
But from over here in the radio region. We're used to the idea of radio signals from intelligent life, or at least semi-intelligent life, radio and television stations. But there are all kinds of reasons why natural objects should emit radio waves. One reason is that they're hot. And when, in 1956, Venus was for the first time observed by a radio telescope, the planet was discovered to be emitting radio waves as if it were at an extremely high temperature. But the real demonstration that the surface of Venus was astonishingly hot came when the first spacecraft penetrated the obscuring clouds of Venus and slowly settled on the surface of the nearest planet.
And before we get to that fascinating voyage/experiment, I need to refill my tea. I'll be back in one moment. Okay. And away we go.
These were the unmanned spacecraft of the Soviet Venera series. In our spaceship of the imagination, we retrace their course. From a distance, our sister planet seems serene and peaceful, its clouds motionless. These clouds are near the top of a great ocean of air, about 100 kilometers thick, composed mainly of carbon dioxide. There's some nitrogen, a little water vapor and other gases, but only the merest trace of hydrocarbons. And the clouds turn out to be not water, but a concentrated solution of sulfuric acid. Even in the high clouds, Venus is a thoroughly nasty place. The clouds are stained yellow by sulfur. There are great lightning storms. As we descend, there are increasing amounts of the noxious gas sulfur dioxide. The pressures become so high that early Venera spacecraft were crushed like old tin cans by the weight of the surrounding atmosphere. Beneath the clouds, in the dense, clear air, it's about as bright as on an overcast day on Earth. But the atmosphere is so thick that the ground seems to ripple and distort. The atmospheric pressure down here is 90 times that on Earth. The temperature is 380 degrees centigrade, 900 Fahrenheit, hotter than the hottest household oven.
Yeah, so Not only is it a very hellish place indeed, but think about that. Like, from a biological species like us, if somehow you could be magically transported to the surface, it's debatable what would kill you first. The pressure crushing your body into a pile of like bone dust and biological fragments, the chemical erosion that would occur, the chemical burning of your skin and your organs due to the sulfuric acid rather, and the other chemicals that are not conducive to our biological systems, or the sheer temperature bursting you into flames instantaneously. So yes, you would survive surely less than a full second if somehow you could be magically transported there, for 3 different reasons.
Is 90 times that on Earth. The temperature is 380 degrees centigrade, 900 Fahrenheit, hotter than the hottest household oven. This is a world marked by searing heat, crushing pressures, sulfurous gases, and a desolate, reddish landscape. Far from the balmy paradise imagined by some early scientists, Venus is the one place in the solar system most like hell. But today, as in ancient tradition, there are travelers who will dare a visit to the underworld. Venera 9 was the first spacecraft in human history to return a photograph from the surface of Venus. It found the rocks curiously eroded, perhaps by the corrosive gases, perhaps because the temperature is so high that the rocks are partly molten and sluggishly flow. The Soviet Venera spacecraft, their electronics long ago fried, are slowly corroding on the surface of Venus. They are the first spaceships from Earth ever to land on another planet. The reason Venus is like hell seems to be what's called the greenhouse effect. The reason Venus is like hell seems to be what's called the greenhouse effect. Ordinary visible sunlight penetrates the clouds and heats the surface, but the dense atmosphere blankets the surface and prevents it from cooling off to space. An atmosphere 90 times as dense as ours, made of carbon dioxide, water vapor, and other gases, lets in visible light from the sun, but will not let out the infrared light radiated by the surface. So the temperature rises until the infrared radiation trickling out to space just balances the sunlight reaching the surface. The greenhouse effect can make an Earth-like world into a planetary inferno. In this cauldron, there is not likely to be anything alive, even creatures very different from us. Organic and other conceivable biological molecules would simply fall to pieces. The hell of Venus is in stark contrast with the comparative heaven of its neighboring world, our little planetary home, the Earth. Here, the atmosphere is 90 times thinner. Here, the carbon dioxide and water vapor make a modest greenhouse effect, which heats the ground above the freezing point of water. Without it, our oceans would be frozen solid. A little greenhouse effect is a good thing.
And I won't spend too long on this or belabor the point, but obviously that depends on the perilous balance of carbon dioxide in the atmosphere, and in more recent decades it has been accumulating at a rate that is astonishing. And this is something that Sagan will address in this version, but it's talked about in more detail and with more current figures and an altered ratio of carbon dioxide in the atmosphere in the Neil deGrasse Tyson cosmos, shot multiple decades later. So we'll look forward to that, if not exactly looking forward to the subject matter from a planetary point of view.
But Venus is an ominous reminder that on a world rather like the Earth, things can go wrong. There is no guarantee that our planet will always be so hospitable. To maintain this clement world, we must understand it and appreciate it. The Earth is a place to our eyes more beautiful than any other that we know. But this beauty has been sculpted by change. Gentle, almost indetectable change, and sudden, violent change. In the cosmos, there is no refuge from change.
The Sphinx, human head, lion's body, constructed more than 5,500 years ago. That face was once crisp and cleanly rendered, like this paw I'm standing on. The paw has been buried in the sand until recently and protected from erosion. The face is now muddled and softened because of thousands of years of sandblasting in the desert and a little rainfall. In New York City, there is an obelisk called Cleopatra's Needle. It comes from Egypt. In only a little more than a century in New York Central Park, the inscriptions on that obelisk have been almost totally obliterated, not by sand and water, but by smog and industrial pollution, a little bit like the atmosphere of Venus. Slow erosion wipes out information. On the Earth, mountain ranges are destroyed by erosion in maybe tens of millions of years, small impact craters in maybe hundreds of thousands of years, and the greatest artifacts of human beings in thousands or tens of thousands of years.
In addition to such slow and uniform processes, there are rare but sudden catastrophes. The Sphinx is missing a nose. In an act of idle desecration, some soldiers once shot it off. If you wait long enough, everything changes.
Idle Desecration would be a great metal band name, just like to point that out.
Of idle desecration, some soldiers once shot it off. If you wait long enough, everything changes. Slow, uniform processes, unheralded events, the sting of a sand grain, the fall of a drop of water, can over the ages totally rework the landscape. And rare, violent processes, exceptional events that will not recur in a lifetime, also make major changes. Both the insignificant and the extraordinary are the architects of the natural world. The destruction of trees and grasslands makes the surface of the Earth brighter. It reflects more sunlight back to space and cools our planet. After we discovered fire,
We began to incinerate forests intentionally to clear the land by a process called slash and burn agriculture. And today, forests and grasslands are being destroyed frivolously, carelessly, by humans who are heedless of the beauty of our cousins, the trees, and ignorant of the possible climatic catastrophes which large-scale burning of forests may bring.
The indiscriminate destruction of vegetation may alter the global climate in ways that no scientist can yet predict. It has already deadened large patches of the Earth's life-supporting skin. And yet we ravage the Earth at an accelerated pace, as if it belonged to this one generation, as if it were ours to do with as we please. The Earth has mechanisms to cleanse itself, to neutralize the toxic substances in its system. But these mechanisms work only up to a point. Beyond some critical threshold, they break down. The damage becomes irreversible. Our generation must choose. Which do we value more, short-term profits or the long-term habitability of our planetary home? The world is divided politically, but ecologically it is tightly interwoven. There are no useless threads in the fabric of the ecosystem. If you cut any one of them, you will unravel many others. We have uncovered other worlds with choking atmospheres and deadly surfaces. Shall we then recreate these hells on Earth? We have encountered desolate moons and barren asteroids. Shall we then scar and crater this blue-green world in their likeness? Natural catastrophes are rare, but they come often enough. We need not force the hand of nature. If we ruin the Earth, there is no place else to go. This is not a disposable world, and we are not yet able to re-engineer other planets. The cruelest desert on Earth is far more hospitable than any place on Mars. The bright sandy surface and dusty atmosphere of Mars reflect enough sunlight back to space to cool the planet, freezing out all its water, locking it in a perpetual ice age. Human activities brighten our landscape and our atmosphere. Might this ultimately make an ice age here? At the same time, we are releasing vast quantities of carbon dioxide, increasing the greenhouse effect. The Earth need not resemble Venus very closely for it to become barren and lifeless. It may not take much to destabilize the Earth's climate, to convert this heaven, our only home in the cosmos, into a kind of hell.
The study of the global climate, the sun's influence, the comparison of the Earth with other worlds, these are subjects in their earliest stages of development. They are funded poorly and grudgingly. And meanwhile, we continue to load the Earth's atmosphere with materials about whose long-term influence we are almost entirely ignorant.
There are worlds that began with as much apparent promise as Earth, but something went wrong. Knowing that worlds can die alerts us to our danger. If a visitor arrived from another world, what account would we give of our stewardship of the planet Earth? In the history of the solar system, have worlds ever been destroyed? Most of the moons in the outer solar system have craters on them made by cometary impacts. Some have such large craters, though, that if the impacting comets had been just a little bit bigger, the moons would have been shattered. What would the results of such a collision look like? Maybe a planetary ring. The idea has been growing that little worlds are every now and then demolished by a cometary impact. The fragments then slowly coalesce and a moon arises again from its own ashes. Some moons may have been destroyed and reconstituted many times. For our own world, the peril is more subtle. Since this series was first broadcast, the dangers of the increasing greenhouse effect have become much more clear. We burn fossil fuels like coal and gas and petroleum, putting more carbon dioxide into the atmosphere and thereby heating the Earth. The hellish conditions on Venus are a reminder that this is serious business. Computer models that successfully explain the climates of other planets predict the deaths of forests, parched croplands, the flooding of coastal cities, environmental refugees, widespread disasters in the next century, unless we change our ways. What do we have to do? 4 things. 1, much more efficient use of fossil fuels. Why not cars that get 70 miles a gallon instead of 25? 2, research and development on safe alternative energy sources, especially solar power. 3, reforestation on a grand scale. And 4, helping to bring the billion poorest people on the planet to self-sufficiency, which is the key step in curbing world population growth. Every one of these steps makes sense apart from greenhouse warming. Now, no one has proposed that the trouble with Venus is that there once was Venusians who drove fuel-inefficient cars, but our nearest neighbor, nevertheless, is a stark warning on the possible fate of an Earth-like world.
Again, much more on that, and from a much more recent empirical framework in the Neil deGrasse Tyson cosmos. Well, there you go, folks. Another episode in the books and restarting again. But yes, as I said, there's a lot to digest there about not only planetary science being one of the drivers of the understanding of our own planet, and more on that as this series goes along, because of course when you learn how to study other planets in terms of atmosphere and composition and long-term geological cycles, that of course has the impact or the implicit development of informing the understanding of this planet in short and long-term cycles. But yes, we're going to get more on other planets specifically in the solar system. The next episode centers around Mars, so anyone interested in the scientific understanding of Mars, as well as some cultural and historical understandings as well, will surely be interested in that. Until then, let me know what you think of this episode, and I will see you next time. Peace.